Hello Motonauts. So this video is going to cover expressions and assemblies. And a lot of people, when they hear expressions and assemblies, they're all, no, I don't want to do that. I don't want to do that. I just want to do the art-friendly part. But really, it's pretty easy stuff. You don't have to be a math genius. Of course, if you are a math genius, you can do a lot more with it. But this is just going to be some really simple expressions, how to work with the expression node in the schematic, and then how to package that up into an assembly. And the expression we're going to be working with is going to be how do you take a couple of values, a range of values, a minimum value and a maximum value, and squeeze that down into another minimum value and a maximum value that you can then use to drive channels in the scene. So a lot of channels in your scene are in the 0 to 1 range, right? Percentages, blends, things like that. And so if you want to drive that 0 to 1 value with another item in the scene that has a value of, say, minimum of 50 and a maximum of 5,000, you somehow have to squeeze 50 and 5,000 down to 0 and 1. And we are going to do that with expressions, although there's several ways to do that. But we're going to do that with expressions in this video so we understand how the expression node works, and then we're going to package it up into an assembly so you can reuse it. Okay, so here's a scene. I assume everybody can make this scene, so I'm not going to go make the scene. But we're going to use physics to get us some values. So let's take our ball here and move it up. We just have a sphere, a pole, and a plane. I already have a physics solver in the scene, actually. Normally that wouldn't be there yet. So what? I'll delete that. No physics solver. Okay, so let's create, let's go over here to our setup tab and under dynamics and select the plane, make it a static rigid body, which means it's basically there to collide with things. Now my physics solver is there. Which was created automatically when I made this a static rigid body. It also has a dynamic tab now. Sphere, we'll make that an active rigid body. And then if you simulate, we have some gravity and a little bit of a bounce and yippee. So not quite good enough. I want something a little more. What I want to do is kind of fling this sphere by our pole here. And depending on how fast the sphere is going, we're going to change this green light to a red light, which I get every time I drive by my kid's school because I drive too fast. And I get the red flashing light. So let's give that a shot. So let's add a little, let's go to dynamic tab on our sphere and add a little impulse in the positive X direction, right? There's a little red X axis going this way, which means that's positive. So we'll do a little 5 Newton force unit pulse there. So now it's going that way, rolling a little bit and kind of staggers across the line there. I'm going to bump up, I just selected both these guys at once, and while I'm in the Dynamics tab, I can change their bounce values up a little bit, maybe friction down a little bit, and take a peek. Okay, that's a little better. All right, so let's just simulate this. Press the simulate button, we've got the frames, hit OK. And it happened really fast. Modo simulates stuff like this really fast. It's just an eye blink. And if I scrub through the playlist now, you'll see that the ball is simulated. So right now, those frames, sort of the transform channels, are being driven by a cached simulation. And what I really want to do is bake those down to keyframes so I can work with the data a little more easily. And also I don't lose it if I want to resim or have this scene dependent on a simulation cache, which you really don't necessarily want to have. So let's bake it down, go to animate, and we're just going to bake. And you just go with the defaults here. There's no constraints going on. That's going to bake all the transform channels. So hit OK. You'll see all the transform channels are baked. And it's doing this same animation. I can now go over to dynamics and make that undynamic. So you'll see the dynamic tab disappeared. This is no longer a dynamic object. If I hit simulate, it's doing nothing, although that's still a static rigid body. So if you want to, you can make that undynamic. But it's not simulating, yet I have my animation because I saved my animation curves. Okay, so let's take a look. Press F7 to bring up your graph, and it baked every single keyframe, and that's fine. That's what we'll use for this. And what we want to measure is the speed, though. So how do we measure the speed of this guy? Well, let's take a look at our schematic and see what we can do with that. I'm just going to drag this guy down here, and you don't need to see all that stuff. Just drag down my dope sheet a little bit. So in the schematic, I've got a bunch of modifiers. So under channel modifier, I have a measure category. And under measure, I've got a couple of things here, speed and velocity. So let me pick speed. I'm also going to grab velocity just so you can kind of see the difference between these two. So when you think of speed and velocity, you kind of think of them almost as the same thing, but they're actually subtly different. They both measure like a distance over time, a meters per second or whatever, where acceleration, of course, is meters per second squared, meters per second per second. Everybody remember that from high school physics? So, but let's just take a look. If we go here, velocity needs, both of these guys need a world position input, and they output speed, and this one outputs velocity. You'll notice velocity is outputting 3 things, where speed just outputs 1 thing. So let's go over here, and you can get a world position a couple different ways. I just like to right-click and say Add Channel World Position. That's the easiest way to do it. And you can feed that into both of these guys. And let's take a drag here. So let's take a look at measure velocity and look in the channels here. Our velocity channels, we've got some meters per second. We've got 3 values. Velocity z is going nowhere because the ball doesn't go anywhere on z. But we've got something in velocity x. It's a positive value, all right, going straight forward in velocity x. And we have velocity y, which up here is a negative value because it's headed down. You can actually see the vector. Modo goes ahead and draws that for you and puts the x and y on screen, which is actually pretty cool. And so you can get to that data, but we're trying to find the speed of something, and the velocity is going, we have a velocity x value that we could use. It just measures it going this way. But what's cool about speed is it's just one channel. Velocity has a direction. The velocity attribute has a direction applied to it, so positive and negative values. And it also has it's broken down into the axes. So velocity is actually a measure of displacement over time, where speed is distance over time. And yes, I Googled this prior to making this video. But the reason we want to use speed is we're just trying to cover distance over time, where displacement, the difference between displacement is if you say you're running on a circular track, you start at the starting line, you run a circle, and you end at the starting line. You have a certain time that took you, but your overall displacement is 0 because you haven't moved from your original position. So that's 0 meters per second squared, or meters per second for velocity, whereas speed is just distance. So it takes the circumference of that track, and that's your distance, and that over your time is the speed. So that's the difference between speed and velocity. And the reason we want speed is just a single value that packages up all 3 of these and gives us a single positive value. So we're going to use speed and not velocity, which is sort of a long way of going around that and saying that. So get a nice readout of speed there, which is kind of cool. So 801 actually has a couple of cool little utilities we can use with this project. Select your sphere, and under display, you can see we've got these new things: add level bars, add meter, add notes. So let's add a meter. And if you click that, now it says remove meter if you want to take it off. Under properties, there's a dial meter pane here. And you can see it on the screen, obviously. You can turn it to a half circle, or show ticks, or don't show ticks. Show value, which let's go ahead and keep that on. Keep it a full circle, that's fine. And it has some channels as well. Units is meters per second, which is what we want. That's what speed is. And we've got a value channel. So let's find that in our channels list here. We've got right here, we've got meter shape. There's the value, min value, max value, show ticks. So that's our meter. Those are the channels for our meter. Let's drag in the meter value right there, right? It's attached to the sphere. It's just a display property attached to the sphere, this channel. And let's plug the speed into the value. Okay, so now, whoops, I'm sorry, not the speed into the value. Yes, the speed into the value. We want to output our speed, which we are measuring, and plug it into the value here. So now we are displaying the measured speed, right? Okay, that's what we're doing. So if you can just hold shift and right arrow and left arrow and sort of tap through the scene, you can see the speed changing. And what we want to do is find out what our minimum and maximum values are, right? What's our minimum value? What's our maximum value? Well, the minimum value is pretty easy. If we go back to 0, the minimum value is 0, right? 0 meters per second. And, I really wish that the text wouldn't scale down really tiny like that, because it's never quite big enough. But anyway, it's like not big enough there, then you zoom in, now it's tiny. So it's like using maps on my iPhone. It's impossible to ever read anything. Anyway, so, that's the brute force way. Let's just kind of tap through this and see where the maximum value is. But, we're smarter than that, so let's see if we can plot that value. Let's just add a locator. I pressed L to add a locator. Okay, right there. Let's drag him in. And let's add a position Y channel. You can select that and just say add channel to schematic. There's position Y. And let's also plug speed into position Y. So now speed is at 0, right? Cover sphere, speed is at 0. Position Y is at 0. As we move forward, speed is at 7.5. And I'm sure you'll know that this is at 7.5. So now we've got our speed driving that locator channel, right? So let's plot that. Let's take a look at this locator, and let's go to animate, and let's bake our locator's motion. So we just did that. You can see all the keyframes created here. And I'm going to press F7 to bring up my graph editor. And let's take a look at this. Now we have our speed plotted. So as I travel along here, really Y is all we care about because that's our speed reading, right? Here it's going down, it's getting faster, and it hits the ground, and it's slow coming back up, you know, and then it's slowing to its peak, and it speeds up with gravity going back down. So it's really easy to look at this plotted graph right here and select that key right here, the topmost one, and see that the top value is 11.48. Okay, so let's keep that in the scene. So we know our maximum value is 11.48, our minimum value is 0, and what we want to try and do in this scene is squeeze our values between 0 and 1, because what we're going to do is our little guy right here, let me press 4 to select that surface, go to the shading tree. This light, we're going to change, do a blend between a green color and a red color, and that blend goes between 0 and 1, depending on the speed of this. So if we can squeeze those values of the speed from 0 and 11.48 to 0 to 1, we can then use that to drive a blend channel that operates on a 0 to 1 percentage. So, okay, making sense? Following me? I think everybody's following me. So let's go ahead and add a, you know, when I started making these, I promised I'd never say, let's go ahead and, because nothing makes you want to punch the screen more during a tutorial than some freaking guy saying, hey, and then let's go ahead and do this, and then you go ahead and do that, and I just freaking said it, so sorry. I'm going to add a constant node. There, how's that? I added a constant node to this light, which also turned it black because it's black color. But I'm going to use some nodal shading in 801 to drive the constant node color, and I'm going to grab a couple more constant nodes while I'm here. So under channel nodes, processing constant, there's one. We'll make this dude red. Red. And we can... Here's a little thing that's annoying with Modo. Control D, duplicate. Not doing anything. Why not? Where's that? I don't understand. If I have, let's say, a math node right here, and I do Control D, I get a... Whoops. I have a math node. And I put Control D, I get another math node. But why isn't that working with a constant node? Well, constant node is really, it's a layer in the shader tree down here under nodes. There it is. When you create nodes in the schematic, they put them in the nodes folder in the shader tree. And the shader tree has a different keyboard shortcut for duplication. In fact, I don't even think it has one. So they need to be able to switch these around, but you can duplicate it in here. You can right click and you can duplicate that. And there you go. I believe that has been discussed at Lexology, I'm sorry, the Foundry, and will be rectified, but right now it's annoying. Okay, so we got a green one and a red one, and we want to blend these two together, so add channel modifier. We've got these new category of channel modifiers in 801, color blend, sounds like what we want. Yes, okay. Zoom in here a little bit. Let's do red on top. Actually, let's do... Now, as it approaches 1, our maximum value, we want it to turn to red. So 0, this is just my organizational capacity of my brain working here. I want 0 on top. So right now, input color 1 is 0, and input, whoops, not this one. We want this is the weird one again, right? So the color is green, but the output value, the computed color, is the texture color. So we want to output texture color into the input color, and then down here, we want to output the red texture color into input color 2. And then we're going to operate with a blend, and so we've got the blend here. There's a couple ways to do this. Again, I can just select blend and add selected. That's an easy way to do it. Now we have a blend amount. When blend amount is 0, let's output the color here into the color of our constant. Okay, and I'm going to go here, go full full RayGL on this guy. Is that full RayGL? Doesn't look like I have any RayGL. Oh, there's full RayGL. So the blend is at 0. So the blend amount is at, it's 100%. And so we're getting, I want to switch these around. I guess 100% is green, and see, my internal brain organization is the opposite of whoever programmed this for Lexology. So let's do, let me switch that away. Boom, boom. Okay, now this should be red, correct? Blend amount 100%. Why am I not getting red? Green, red. Huh, looks like RayGL. There we go. Little bug. Not upgraded SP1 yet. Maybe that's fixed, but okay. So at 100%, it's red. Eventually, so we're going to pipe our speed in here. When our speed is equal to 1, when we remap those values, it'll be red. And our speed at 0, starting off, will be green. Okay, the warning light. Okay, so that makes sense. What we need to do now, obviously, is drive our blend amount by our speed value, but we need to remap that speed value of 0 to 11.48 into a 0 to 1 range. And now we are finally getting to the part of the tutorial that matters. So, all right, so let's get going on that. Locator node, I don't believe we need any more. We all have fairly good short-term memory here, right? So the maximum value is 1148, minimum value is 0. Keep those in mind. Delete that guy to clean it up a little bit. Now it's time to dig into the expression node and remap our values. So under channel modifier other, expression, get this funny looking node here. Zoom in a little bit. Here we've got input A, B, C, D, output, and expression. You can look it over here on the properties value. Okay, what in the world is that? So it's actually pretty easy. These are variables that we can use. We can either type numbers into the slots, or we can plug in channels to drive those variables to get values that way. And here in this little window, we type in our expression, or in this sample expression, it comes with A plus B. So if we say A is 5 and B is 2, guess what that's going to give us? Let's go to the channels tab. So our expression, A plus B, A is 5, B is 2, A plus B, output 7. So this output, spitting out a 7. Let's say we take our speed, which on frame 30 is, select our ball, we've got our meter, 10.7. So we take speed and put that into D and go back to the expression. And I could just type it in here. I could type it in here, or just on the channel thing here. Let's say A plus B plus D. And we've got 17,338 because that is 10, 7, 3, 3, 3, 8 plus 7 is 17, 3, 3, 3, 3, 3, 8. 7, 3, 8, 8. Anyway, so it's also clear to you now, right? So here's the variables. We can plug numbers. We could plug channels in there to get a number, or we could just type in numbers. And we have a whole bunch of functions, sine, cosine, tangent, anything, absolute value, min, max, sum, average, all these different functions. Or operators, plus, minus, logical operators, less or equal, greater or equal. All of these are available to us to use in our expression, which is great. We're actually not going to use many of these. For remapping a value, we need an equation to put into our expression. And the equation for remapping two values, a range of two values, into a different range is just something I Googled up. It's not something I remember from high school or doing my everyday job of rocket science. I just Googled it. So our new value, that's the value you want to output to the blend mode of our blend node, or the blend value of our blend node. The max value here, the new max value is going to be 1 minus the new min value, which is going to be 0. Our current max value is 1148. We plotted that on that locator, and our old min value is 0. And then we multiply that by the value. What is that? The value. That's the current value. That's our speed, right? That's our current value. And then minus the max of that current value, and then adding on the max of the new value, or remapping that to. So it's kind of a long one, but let's take a look. We've got 1, 2, 3, 4, 5 variables. We could actually run this entire thing through the expression here. We could just go to our expression and type in We know our new max is 1 minus our old max, or our new min is 0. So 1 minus 0, which we just put 1 divided by the old max is 1148 minus the old min is 0. So 1 divided by 1148, and then multiply that by the value, which was d, minus max, which is 1148, and plus the new max is 1. Okay, so we could type that all in, and we're only using one variable for value. But we don't want to do that. We want to replace all of these with variables because we want to reuse this expression that we're putting all this effort into, this remap value expression, in an assembly later on, and use this in other scenes. In other scenes, we are going to have different max and min values that in our scene that we're sampling from, and we'll probably have max and min values that we want to remap to other than 0 and 1. So let's keep these all as variables, and then we can input in our assembly, we can use that to input new values in there to sort of generalize this whole expression. So back at the expression, I'm going to unplug D. Let's do it this way. Input A, we'll just do it over here. And we can do this just in our, there's a couple ways to do this. One, we can, let's say you want to plug something in. Well, Modo doesn't have a scalar node, a node with just a number. So you would use something like a add node, and you would just say 11.48, plus 0 is 11.48, and we'd plug it in that way, and now we have 11.48 in our input A. So there's a couple ways to do it. Right now I'm going to do this. I'm just going to say 11.48 for input A. Oops, I'm sorry, not 11.48. We want our new min value, new max value that we're mapping to. We're going to call that 1, right? Our new min value is going to be 0. Our current max value is 1148. And our current min value is 0. And our current value is what? Get rid of these. Is what? We're out. We're out of variables. What do we do? So what do we do? What do we do when we're out of slots to put in variables? So fortunately, Modo will let you use a user channel as a variable in the expression string. So all we need to do is add a user channel. So we can do that here, add user channel. You can also do it actually from the channel list here, add user channel, which I'm going to do because I like seeing all this stuff in there. So let's call it normalized, value to normalize, right? Actually, we should call it, well, let's just call it that. Value to normalize, okay? And when I hit tab, you'll notice it takes out the spaces. Okay, so let's remember that. In fact, I'm just going to copy that right now. Command C, copy, value to normalize. So when the spaces, that's the human name, right? The username. The computer doesn't want the spaces in there. So the value to normalize no spaces is the real name of the channel. That's just the human readable name. So when we do an expression, let's put a number in, value to normalize. Let's say 4. And we do an expression, and we say A plus value to normalize. Actually, I should have just copied it since I took the time to paste it. But and hit return. I should be getting a big fat 5 here. 4 plus 1 equals 5. And why is that not happening? There's a bug. There's a bug in Modo. It's not updating the expression node with the user channel. So that has been bugged. They're aware of this. Top people are on it. It should be fixed. In fact, if you're watching this post SP2, it's probably already fixed. But let's take a look here and see if there's a trick for seeing these types of things. If you go to the event log, you will see expression, object, loader, saver, error, unexpected token, value to normalize, found at position 2. That's position 2 there. Position 1, A sees that. Position 2 does not recognize that as a variable. And you can see that here in the event log. In fact, you see this little tiny microscopic 1 pixel size triangle here, which is just unbelievably tiny. If you click that and go to viewport controls, you can turn off min header. You get the headers back, and we'll click the gear, and you can actually look at the master list here. This is where you probably started. You can also look at the event log of just the expression engine here. So there's expression. See, bet you didn't know you could do this. So I see this is not working. That's okay. There's a couple of ways to work around this. I'm going to go ahead and close this now. There, I said it again. I just said I'm going to go ahead and do something. I swear I'm going to stop saying that. Okay, where was I? All right, so there's a couple of ways to deal with this. We can just save the scene, close the scene, load the scene, and this will now work. Okay. There you can also update it in the scene just by, we'll say, add a locator, and let's throw it in here and add the Y channel and hook up the output. Here, watch this. Let me select the expression node, go to channels here. It's not outputting anything, but I hook up the Y channel, and all of a sudden it snaps into shape, and we're doing a plus value to normalize. 4 plus 1 equals 5. Now it's working, so I can do that, or just save, close, and reload the scene. Again, unfortunate bug, but it should be fixed. Plus, you learned about the event log, so isn't that fun? So all right, now we have all our values in here. So now we need to create an expression. The expression is, of course, right here. New max minus new min divided by old max minus old min. So expression, we'll just clear out that guy and say new max, which is the new maximum value is going to be A minus the new minimum value B divided by the old maximum value C minus the old minimum value D, parentheses. Okay, so we've made it here thus far. Now we have to multiply that by value minus max. So multiply that by value. What is the value? That is value to normalize. Let's look that up. Our speed is our value to normalize. So remember we called that value to normalize right there. And we subtracted the max value, the old max value, then added, and then we're going to add the new max value at the end. So value to normalize, in fact, I need a little parenthesis there. Parenthesis, value to normalize minus the old max value, which was C, parentheses, plus the new max value, which is A. Correct? Correct. And that's it right there. Hit return. And it just gave me some weird, oh, it gave me like half of that for some reason. Okay. That appears to be a bit of a bug. Let's see if we can do this again. Sorry about that. Hopefully that didn't happen to you. Multiplied by value to normalize. Minus C plus A. Return. Okay, now it's there. Fantastic. Let's take a look here. What do we have? We have 0.9. Why is that 0.9? Well, it's 0.9 because we're going really fast here. That's near our maximum value. So 1 is our maximum value, remember. The most we're going to get out of this when it goes to 11.48 is 1. And if we go all the way back to frame 0, we get 0. Okay, there's output is 0. So our expression is working. It's normalizing our speed values that go between 0 and 11.48 to a new range of 0 to 1. And we can use that to drive the blend amount here. So let's drag the output to the blend amount. And I'm just going to turn this to a real live preview to get a better look here. So we've got green at the 0 mark, and as we go forward, we hit red as it goes. Gets increasingly red as that gets increasingly close to 1. We're at 0.9. As it bounces, it's kind of going to go back to green. So that's basically working. That's what we want. However, we don't want it to be all these shades between, red and green. We just want it to be red or green. So how do we do that? Well, we can adjust this value post the expression node prior to going into the color blend. So with this selected, let's add a conditional. Let's say logic. Let's say logic A is less than B. Let's do that. Logic A is less than B. And because I had that noodle selected, it just inserted that logic node right in between there. So let's think what we have now. Value A is what's coming in out of the output. So value A, right now we have basically at frame 0, we have 0 coming in at value A. And really, we want it to stay green until we get going pretty fast here, until the ball is, remember we've got our meter here, is about, let's say, 9 meters per second, which in our expression node is about 0.83. So let's say around 0.8, it goes red. Anything above 0.8, we want this light to go red. You're going too fast, you gotta stop. Anything below 0.8, it goes back to green. So let's look at our logic node here, and logic, and we have A is less than B. So if A is less than B, and value B is, let's say, 0.8, so if A is less than B, we want green. So we want to actually just spit out, we don't want to output value A, which is going to be anything between 0 and 0.8, because we just want green. So if this is true, if our normalized speed value is less than 0.8, we just want to output value B, Okay, if true, output value, output true value. You want to output the true value. So we know this is going to be true. We can insert our own true value, and we'll just keep it at 0 because we want to keep this thing at green. And then if false, in other words, if a is actually greater than 0.8, we don't need to output the false value or value a, or we don't want to output value a, which is going to be between 0.8 and 1. We want to output a full-blown 1. We want a full red. So we'll output the false value, and we'll call that 1. So now we are either outputting 0 or 1. If it's less than 0.8, we're doing 0. If it's greater than 0.8, we're doing 1. I just go through here. I may have this reversed. Yep, so let me just reverse that really quickly. So why is this? Color blend, if speed is less than 0.8, we're outputting 0. So if it's less than 0.8, we're writing 0, and the blend amount is 0. So a quick way to do this, we could switch our logic nodes, or I could just switch my, I think this is the second time I've done this, switch my texture color outputs. So now we have green, right? We have red just for a very brief time when it's going very fast. But basically we're going green, 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 green. And then right when we're going very fast, right here near the bottom, we're going too fast for the red light. We get the red light warning. Then we're bouncing. We lose all our energy. We're going slow. And we're getting green now. Okay. So we've successfully used an expression to remap our range of values into a 0 to 1 range of values, and use that with the help of a little logic node to drive a blend to do something useful in the scene. So that was a long way around learning how to use expressions and using the variables in expressions, but I think it's worthwhile. And what we're going to do now is save this out as an assembly so we can use it in another scene without having to do all of this again, which would be nice. So an assembly is a package of items and channels that has certain inputs exposed to the user and certain outputs exposed. And I'm going to put this together really quickly here. Let's go back. If you press this little button here, it goes back to sort of the list of workspaces. And we have just the single workspace. If you double click, we're in that. We go back to our list of workspaces. We don't have any assemblies in the scene now. So this little gear plus icon over here, press that, and we have a new assembly in the scene. We'll call this normalized value range. We'll call that the assembly. Normalize value range. There's our assembly. And we can go right into our assembly here, like this, or we can go back to our scene, our overview, and drag and drop our assembly into the workspace. Double-click the workspace. Now we're in our workspace, and here's our assembly. So how do we get this expression node into this assembly? Because if I just do that, I can't seem to drag and drop it. It doesn't seem to work. So what you can do is you can right-click and move it to the assembly. So I can move this to the normalized range value assembly. I'm going to unhook these first, actually. And then I'm going to take this single expression node, move nodes to assembly, normalized range value. Whoops, did that not do it? Right-click, move nodes to assembly, boom. Now it's there. You'll see this gear icon comes. So I double-click here. Voila, there's our expression node in our assembly. And so we've got an output, assembly outputs here. And there's a couple ways to do this. One way we can do it is just take our output, highlight it, right-click, and say expose channel as output. Now, our output, we are outputting, if I come back up, this up arrow here, out of the assembly, we see we have an output channel here. That is outputting the result of this expression. That's what we want. However, because we want a generalized expression here, the reason we used variables, if you remember, is some other scene is going to want a new channel to normalize, and it's going to have a different minimum and a different maximum, and you're going to want to remap those between not just 0 and 1, but maybe something else. So we want these variables normalized, we want these variables exposed, so you can drag this assembly into a new scene and input your all your mins and maxes and the one you want to normalize, the channel you want to normalize, and run it through the expression. So we go over here, and our assembly inputs, instead of exposing things, let's give them some custom names. So press the little plus channel here, and let's call this first one, remember in the scene, channel A is our desired maximum value. So we'll call that desired max value. Sounds good. Tab, hit return. Do another one. Desired min, whoops. Desired min value, tab return. Remember, if we go to the expression here, that's our desired max, A, desired min, B, regular max, scene max, C, scene min, D. So let's keep adding these. Current max value, we'll call that, tab return. Current min value. All right, very exciting, watch me type. And then value to normalize. We can call that, let's just call it channel to remap. That's maybe better. Channel to remap. I probably should have called that. But now, before I rig these up, I'm actually just going to zero this out. 0, okay. Because we're going to use these values that we're going to be inputting from the outside the assemblies. So desired max is A, desired min is B, current max is C, current min is D, and channel to remap goes into value to normalize. And now we have an assembly. So if I pop out of here, I should be getting the same thing I got before. When I was way up here, we're looking at a, let me just turn this to full-blown, whoops, preview, sorry, preview. We're looking at a green guy, and as we get closer to the floor, it turns red, and then we bounce, lose our energy, and it's green again. Okay, so we've just consolidated that expression node into an assembly that we can use in another scene. So how do we do that? Well, let's select our assembly. The first thing I want to do before I save this is just, this is a sort of a caveat if you're on the Mac side. Go up here to System and open the content folder. Okay, so if you right-click on the heading here, you can see where that came from. Came from the library directory. And on the Macintosh, and I think since Snow Leopard, maybe? Mountain Lion, the library is now hidden by default. It's idiotic, but it is hidden by default. Not only is it hidden by default, it is unsearchable by Spotlight. So even though application support is where all vendors are supposed to put their assets, which the Foundry is doing correctly, it is unviewable. You can't even get to the library under normal circumstances unless you type in a terminal command to make it visible. And you certainly can't even search for it. So, that's stupid and it sucks, but if you're a Mac user, you've probably already realized that, and you've typed in the command, I can't remember what it is, to make your library visible. Because I really think we should put this in the library so we can get to it easily with our asset folder. Let me just get back to Modo here. So selecting our assembly here, it's just going to save what's selected and what's inside the assembly. Anything that's not inside this assembly is not going to be saved with the assembly. You can also see a hierarchy view here, this assembly within the workspace, which is kind of cool. So let's select the assembly, File, Save Assembly. I already have it here. I put a custom folder inside my assembly. We've got particles, cameras, and I put a custom folder there. And I'm calling this remap value range. I'm going to save that, replace, let's save that guy there. And now I've saved my assembly. So let's put our assembly to use. Command N will create a new scene. And I don't really need this anymore. Let's just make this perspective view with a grid on there. So really quickly, I'm just going to add a cube and a sphere. So we get a cube, we got a sphere, right? So our cube, let's Shift W, create a keyframe at 0, go up to frame 100, and say in Z, let's type in some random number like 16.154. Great, okay, so at frame 100, that's where it is, 16.154. And this guy, then we'll just drag both these guys actually into the schematic. Okay, put the sphere here, the cube here. We want our Z channel there because we're going to remap that guy. Let's say we want to adjust the Y value of the sphere with the Z value of this. So now let's bring our assembly in. Pressing F6, we have a preset browser, and we can just drag and drop our assembly in that we created. And here it is. Here's our assembly, which is so cool. All we have to do is put the output into the Y position that we want to. Let's do that last, actually. Let's do the Z input to the channel to remap. We're remapping the Z channel. So let's plug that in, select our assembly, and over here in assembly channels, I thought I cleared those out. Didn't I clear those out? Maybe I didn't clear those out. Clear them out. Clear them out, then resave your assembly. So what do we say? Desired max value. Well, let's give it something weird. Let's say our maximum for our sphere on Y, we desire 7.54 Y, and our desired min value, say 3.5 Y. Our current max value is, what is that? If we grab our cube, it's 16154. So assembly channels, current max, 16.154. Current min value is 0. Okay, and then if we plug the output into the Y position here, look, at minimum, this is, what, 3.5, correct? 3.5, and at maximum, it goes to 7.51 or some weird thing there, I believe. 7.54. So we've remapped our values into a range and are using them to drive a sphere with our expression assembly. So yay, we're awesome. Let's create another sphere just for fun. And let's do something else. Let's bring up our, let's go to animate and channel links. And let's grab our cube and say load driver and grab sphere, whoops, wrong scene. Grab sphere number 2, load driven, and cube, load driver. And let's take a look at this. So let's say Z, and on the sphere, let's add the position, channels, and Y. And we'll say relationship and add link. Okay. Hit OK. And we have this little weird thing coming up here. So what basically this does is it lets you set keyframes in a channel relationship. Actually, I like to work with the graph editor. So we can bring up a graph editor here. And value 0, 0, 0. Let's put this up to, let's put this at negative 3.5. And let's look at our value here. And do a middle click another keyframe, and at 16.154, let's say negative 7.54, and let's make this linear. And let's take a look at hit escape twice. Take a look at what we're doing here. Interesting. Looks sort of familiar, doesn't it? So correct. This assembly we made, you can already do very easily. In fact, let's take a look at our cube here. This has some more. Let's double click our Z. There's another node that was put in, a relationship node that goes to sphere number 2. And this was created when I did the channel links. In fact, if you select it, you get the interface up here, which I'm not going to go over right now if you haven't used it. But you can see I'm going between the keyframes here, 1 and 2, and the values that are remapped. Or you can bring up the graph editor. So what we just did with our expression and our assembly, you can, in fact, do with... I just take out the animation on this guy. I think I did. There we go. You can, in fact, do with a relationship editor, because that's what we did. We created a relationship when we remapped these values. So this thing we just spent an hour making isn't entirely useful because we could already do it in Modo with a relationship modifier. But now you know the relationship modifier is essentially this expression we just did, right? So pretty cool. And it works the same way. It's just this assembly works as a package node for here. And if I double click here, we just have this one expression here, but I could, add in some clamp values and do whatever else before I output this value. In the other scene, we did that afterwards, but this can easily go into the node here, and you can put whatever else you want here as well. So assemblies are very useful. You know how to make one now. You know how to use the expression node. You know where to save them so you can bring them into other scenes. And you know what we just did is you could already do even easier than in like 2 seconds using the channel links. So there you go.